Globally, water quality is at risk. Human activities cause pollution by releasing harmful substances into our waters, such as nutrients, pathogens, chemicals, metals, plastics, and others. As a consequence, our ecosystems and human health are threatened, and there can be other impacts, for instance, on food security and energy production. The most recent Sustainable Development Goal 6 Synthesis Report 2023 shows that 42% of household waste is not treated, and that, even though 60% of water bodies was reported to have good ambient water quality, global trends can hardly be addressed because measurements are frequently unavailable, in particular in low GDP countries and for groundwater. Also, a limited number of other reports evaluate water quality and highlight lack of monitoring data as a large problem. Water quality models provide opportunities because they give insights where there are no measurements. What are water quality models and what are they used for? Water quality models simulate concentrations of pollutants, such as nutrients or chemicals in the water, based on how we think these pollutants behave in the water.
In our case, we use mostly the process-based mechanistic model, so they try to track the fate from input to the land and then going to the river water bodies, and it can come from the agriculture or from wastewater treatment plants and other sources like the industry, households, our human emissions. And what we try to do is in the modeling that we use the best available knowledge of how the different processes happens, how much decay process happens in the rivers. We use a variety of data sets which is publicly available sources like how much fertilizers are used, how much pesticides are put up, or population data, what is the connection and sewage and treatment connectivities.
So models are helpful tools. The large-scale models, particularly the global models, they help us to provide information and data to all those regions where we have no monitoring available. So data scarce areas can benefit from the global modeling so that we can get a view of what's going to happen, particularly in those regions. And on the other side, models help us to identify hotspots where either concentrations are above certain thresholds.
These are areas where problems are largest and interventions most urgent. Additionally, the models help us to identify main sources of water pollution, which can guide specification of sources that we need to focus on to improve our water quality. Finally, we can use models in experiments. In these experiments, we can assess future trends in water quality. We can, for example, evaluate how population growth and future development are expected to influence water quality. Or we can simulate how climate change influences the water quality. In other experiments, we can evaluate the effectiveness of interventions on the water quality. We can, for example, show how the water quality changes when wastewater treatment increases. All these opportunities of water quality models are essential for the development of a world water quality assessment. Such an assessment was asked for by decision makers from nations that gathered during the United Nations Environment Assembly in 2017. The assessment would provide the state of water quality worldwide at present and for the future, in addition to understanding on the impacts of water quality and recommendations on interventions. Water quality models at smaller scale levels, such as city or basin levels, can also help decision makers to identify solutions and priorities for improving their water quality. The large-scale and regional water quality modeling community has been gathering regularly over the past years. Water quality models have previously been developed for different objectives and different pollutants, and therefore show a large diversity in water bodies, pollutants, and also in spatial and temporal scale and level of detail. In order to identify robust hotspots and sources of water pollution and trends into the future, our models need to be streamlined. This means that they will need to use the same consistent input data and provide water quality at the same spatial and temporal scale and with the same level of detail. We can use the model outputs to compare our model results, which helps to build trust in our conclusions. Additionally, we are in the process to develop new water quality scenarios for the future. These scenarios include future developments of water quality, taking into account plausible changes in the different input variables, such as population change, socioeconomic development, and climate change. First results of our joint efforts are maps of concentrations for 2015 and 2050. In these maps, we evaluate for several pollutants whether water quality standards are violated or not. When zooming in to chemicals, we can see that the area where standards are violated increases, for example in Africa, Latin America, and Southeast Asia. Taking all the pollutants into account, we concluded that water quality standards are exceeded in large parts of the world already now and even more so in the future, with increasing violation in particular in low GDP countries. The reasons for increasing violation of standards include population growth and wastewater treatment improvements that do not keep up with this population growth. Both of these factors are more severe in low GDP countries.
We will first publish our preliminary results in international scientific journals. But then, by integrating our models and scenarios, we will get a much better understanding of where pollution takes place and why. It is a community effort. As a community, we participate in the World Water Quality Alliance and we contribute to the intersectoral impact model in the comparison project. We also contribute to global assessments, such as for the IPCC on climate change. And with all of this, we contribute to the achievement of Sustainable Development Goal 6 of the United Nations on clean water for all.